Everyone, welcome to lesson 5. In today's lesson, we're actually going to be doing a virtual lab. So going to be a little bit different than our previous 4 lessons. Again, remembering we are in our unit 3 on momentum and collisions. All right, and so today it'll be a little bit more fun, in my opinion. So when you guys go into Canvas, you guys should see lesson 5 collisions lab. You open that up, you guys will see that there are a couple of links in here. Again, one is the link to the video. Then you're going to want to access our assignment. Again, I have a Word doc version and a Google Doc version. Just do whichever one is easier for you. Once you click on that, right, it'll open up your assignment. First thing you want to do is you want to click on this link above. Right, you click on this link, it will take you to our virtual lab. All right, so fix that right now. Why? It's invalid. There you go. All right, click on that. Will bring us to our lab. All right, now this lab is pretty simple, right? You just have 2 objects. One object is going to move. You can actually set it up so the object moves as well. And they are going to collide. And we're going to see what happens when they collide. Again, we're talking about momentum, so we want to see will momentum be conserved. All right, now a couple things that you want to do. Let's go ahead and look at our instructions. All right, so we're in part 1, scenario 1. One of the things we want to do is we want to click on more data to expand our data table. All right, so our more data button is down here. Let's click on that. Now you see we get a few more options in here. All right, going back to our lesson. We want to make sure that our controls match the controls over here on the right. Again, by default, it should all be the same. Elasticity is 100%. Look at my lab here. Elasticity is 100%. Perfect. The velocity vectors is checked. Nothing else is checked. I think we're good. All right. Now it's asking me to make a hypothesis about initial and final momentums of these 2 objects when I'm playing around with the sim. Now, again, what that means is I want to say what's going to happen to the momentum both before there's a collision and after. Basically, is momentum of these 2 objects before the collision going to be the same as momentum after they collide? All right. So you can see there are a few variables down here that we can change, right? We can change the mass of our red ball. We can change the mass of our green ball. We can change their positions. We can also change their positions by just clicking and dragging them. See how that begins to change. We also change the velocity, right? You notice if you change their velocity, what starts to happen, right? That velocity vector arrow gets a little bit bigger. Okay. Let's see. Make your hypothesis, right? Is momentum going to be the same before as it will after, or will it look a little different? Okay. Let's look here. All right. So what we're going to do is we want to have an 100% elastic collision between 2 balls of equal mass. Now, remembering the difference between elastic and inelastic, remember, elastic collisions, right, they kind of bounce. They should conserve both momentum and kinetic energy, right? So let's see. In here, we need to type in what's the mass we're going to use, right? We can kind of change this, right? You can have your balls have a mass of 1, whatever you choose. We want to make sure that they're equal. Velocity is already set for us, and then we want to fill in our momentum, right? So let's go ahead and do that. Let's say I want both balls to have a mass of 1. Again, you can choose a different number. So make both these balls have the same mass. All right. Already have the velocity set. All right, then I want to fill in momentum, right? So my red ball has momentum of 1. And remembering we get this momentum through our momentum formula, which is momentum equals mass times velocity. In this case, our mass is 1, our velocity is 1, so 1 times 1 equals 1. Okay, 1. And then for ball 2, also has a mass of 1, has velocity of 0, so 1 times 0 equals 0. Okay. And then what is the total momentum then? Right? 1 plus 0 equals 1. All right. Pretty simple so far. So this is our total momentum before the collision. Now we want to see what's going to be total momentum after a collision. What we can do is we go back to our simulation. We can click play. There's a collision. Let's go ahead and pause it. Right, it'll keep moving. Now let's take a look at what has changed. All right, so let's look at our mass. We have a mass of 1 and 1. All right, obviously, in this case, mass did not change. Pretty much the same. So mass is still 1 and 1. What we want to look at is we want to look at what happened to velocity. I notice that the red ball is no longer moving. There's a velocity of 0 now. Okay, so our velocity is 0. Our green ball, on the other hand, is moving, right? It has a velocity of 1. Go ahead and type that in here. All right, now we can figure out momentum. Right? We know, again, momentum equals mass times velocity. So 1 times 0 is 0. 1 times 1 is 1. Figure out our total momentum. Right, it's just adding them all up. So 0 plus 1 equals 1. All right. So now we want to just kind of compare, right? Before and after. Our momentum, total momentum before the simulation was 1. Our total momentum after simulation is also 1, right? So is the law of conservation of momentum true, right? This idea that momentum before, momentum after collision are going to be the same. Looks like it is. Right? Trial 2, again, what you want to do is do this exact same thing, although this time you can change the mass, right? Just make sure that both your masses are the same. Again, if you want to, you can change this velocity. I just kind of set one up just so there'd be fewer numbers for you guys to have to mess around with. So figure out what's the momentum going to be, have them collide, figure out what the new momentum is going to be. All right, when you guys get into scenario 2, the only difference is we want to make it where you have two balls that have different masses or unequal masses, right? So maybe one ball has a mass of 1. All right, let's restart this. Let's say one ball has a mass of 1, the other ball has a mass of 2. All right, and then just kind of seeing how does this change the relationship when there's a collision, right? Are we still going to have the same amount of momentum both before and after? All right. So again, kind of play around with it. So in this case, they end up moving away from each other, right? So you can kind of add it up and then see, are we still getting the same total momentum both before and after? Just kind of play around with that. We're going to do that twice. Quick question. What's the relationship between initial and total momentums in scenario 1, scenario 2, right? Is it the same relationship? Describe the motion of the balls before and after collision scenario 1. Describe the motion of the balls before and after the collision scenario 2. All right, then we get into part 2, right? The main difference in part 2 is that we're going to change the elasticity, right? So in our lab, I'm going to reset all this. So we can change the elasticity by changing this little slider over here. So you want to start by setting it to about 25%, right? So if we're thinking that like a bouncy ball is close to 100% elasticity, then maybe like a foam dodgeball, maybe not even. Yeah, well, yeah, let's say like a pretty cheap foam dodgeball maybe has the elasticity of 25%. Probably not the best example. All right, so let's kind of look at what happens. I think this. And this one, I guess it doesn't really matter. You can have equal masses, you can have unequal masses for both your objects. Really, we just want to see what happens when we have two objects where they are not perfectly elastic, right? What's going to happen? What happens to momentum before and after, right? Is momentum still being conserved? Like in scenario 2, you're going to change elasticity to 0%, right? We're going to make this perfectly inelastic, right? And just looking at what happens when it is perfectly inelastic. Is momentum still being conserved? In the last scenario, you guys can choose your elasticity, right? You can set it to 1% maybe, 50%, 75%, 99%. You just get to kind of choose one, right? And then taking a look at what happens. Finally, this is your initial hypothesis from the very beginning of this activity, accepted or rejected, is momentum conserved. And then just as a short paragraph, just talk about what are some of the main ideas that you learned in this activity in terms of initial and final total momentum in these collisions, right? Kind of what happens in perfectly elastic collisions versus perfectly inelastic collisions versus partially elastic or partially inelastic collisions, right? Again, feel free to play around with this even more. There's more that you can do if you guys want to go even more advanced, right? You can click on this advanced tab up here. You can see if we're looking at 2 dimensions instead of 1 dimensions, there's going to be some even more complex interactions there. You can even add more objects and see how this continues to affect momentum and collisions, right? Just the math gets a little more complicated. You guys can also consider, what's happening to the total kinetic energy. Notice here, even though there's a lot of activity going on, the total amount of kinetic energy is not changing. All right, if you guys have any questions, feel free to shoot me an email. Don't forget about office hours. Office hours you can get to by going to the conferences tab of your Canvas page. Again, conference hours for advanced physical science are going to be every Tuesday from 1 to 3 p.m. For regular physical science, it's going to be every Wednesday from 1 to 3 p.m. And for physics, it will be every Thursday from 1 to 3 p.m. All right. Stay safe. I'll talk to you guys later.